Hey guys, I hope you're having a good weekend. This is Mrs. Fraser, and we are going to look at direct variation this weekend. So before we get started, make sure that you have your note sheet that you got from your teacher on Friday. And if you don't have that, you can go to Canvas if you're in Miss Horgan's, Miss Levi's, or Miss Jones's class, or to Edmodo for Miss Duwalk and Miss Fraser's class. So we're going to go ahead and get started. Make sure that you have a pencil and a highlighter. And remember, you can pause the video at any time if you need to catch up or take a break. So let's go ahead and get started. We're going to talk about direct variation. So proportional relationships can also be referred to as a direct variation using the form y equals kx. The graph of y equals kx is linear and includes the origin 0, 0 as a point on the graph. The constant of variation, k, is the quotient y over x. So far we have looked at slope as change in y over change in x, but today we're going to explore when slope is k in a proportional relationship and it's just y over x. So we actually don't have to find the change in y to the change in x. So let me give you an example. So here we have a table, and you can see it goes to the origin, which is one clue that it could be proportional, but not the only thing that will tell me if I have a direct variation or a proportional relationship. I still have to make sure that it is linear, that it has a constant rate of change. So be sure to check that. So if I find my constant rate of change here, I can see it goes from 0 to 4 for the change of my y, and from 0 to 2 for the change of my x. So my slope would simplify to 2. Well, since this is also proportional, I know that I can do y over x. And the reason why I know I can do it is if I just take y 4 over the x value 2, I get 2. As well as if I take 8 and put it over 4, I get 2. If I take 24 and divide by 12, I get 2. So because I can do that for every y to x value, it is a direct variation or a proportional relationship. So let's look at an example when that's not true. So the first clue is that I have a value with my, when x is 0, I have a y value of 2. That means it's not passing through the origin, but you can't always see that. So I can still see that this is a linear relationship because I have a change in y of 4 and a change in x of 2 for each of those, and the slope would be 2. Except if I go to see if I have a direct variation, I can take 6 and put it over 2, which equals 3, and then I would take 10 and put it over 4, and that doesn't equal 3. That equals 2.5, and because those ratios are not equal, this is not a direct variation. It is not a proportional relationship. Okay, so we're going to move on to the next part of your notes. So let's look at when we do have a direct variation, what that can mean. So let's say y varies directly with x, which is how you will see it. Y equals 45. X equals 9. When that's true, I can just take my direct variation formula, which I know is just y over x, to create my equation for the line, or to find my constant of proportionality. So what is the constant of variation? I just take 45, I divide by 9, and I get 5, which is my slope as well. So we call it the constant of variation because it's a proportional relationship. So that means my equation for the relationship is just y equals 5x. Okay, so we're going to take this relationship and look at this relationship in a table and also look at it in a graph. So if I have y equals 5x, I'm just going to choose some x values here. I'm going to pull this over. Oops, sorry about that. For some reason changes color sometimes. Okay, so I have 0, 0. If x is 0, then y would be 0. If x is 1, then y would be 5. And if x is 2, y would be 10. If x is 3, y would be 15. So all I'm doing is plugging in the y values. So if x is 4, 5 times 4 is 20. And if x is 5, 5 times 5 is 25. Okay, so I've already graphed this relationship, so I'll give you some time to graph it as well. And I didn't graph every point, I just graphed the 0, 0. And I also graphed the 5 and, I'm sorry, the 4 and the 20. And then I knew from those 2 points that I could create a line. Notice that the line is straight, it's linear, and it goes through the origin. Okay, so then what if I want to find a little further out? How can I use direct variation to help me? So say I want to find y when x equals 15. So you can see the answer here is 75, and you're going to see how we got that answer. If I found the equation of my line as y equals 5x, I'm just going to plug 15 in for x. So y equals the constant of variation, or the slope, times 15, and 5 times 15 is 75. Okay, so we're going to continue on. Remember, you can pause if you need to catch up at any point. So let's look at a situation, a direct variation situation that you might see. The grade you make on your exam varies directly with the number of correct answers you can get on the exam. Okay, so this is important to notice some things that have already been underlined for you. First, before we can even begin to solve, we have to determine which value is our x and which values are y. I'm going to go back to your previous page. I've kind of color-coded things for you. You can see here I put 45 over 9, and 45 was my y value, it's green, and 9 was my x value, it's orange. So I've kind of color-coded things for you to see how things go. So I'm going to grab a highlighter. I'm just going to grab orange here because that's my x value. Or actually, let's start with green, my y value. Okay, so in this relationship, when it says the grade you make on your exam varies directly with the number of correct answers, we're going to go back and think about independent and dependent values, or variables, I'm sorry. So the grade you make is dependent upon the number of correct answers you get. So grade you make would be my y value, and I'm going to highlight the x value yellow since I don't have an easy orange to grab. Or actually, let's see. Let's grab right there. Okay. And the number of correct answers would be my y value. So that's important to make sure you make that differentiation between the two so you can set up correctly. So say I got 15 questions correct. So the questions are actually my x value. So 15 corrections correct. And we earned a 75%, a grade of 75%. Oh, sorry about that. Not very neat, but you get the point. Okay, so a grade of 75. What would be my constant of variation? Okay, so first we're going to start by finding the constant of proportionality so we can create our equation. So we're finding the slope, or k, in this situation. So since it's direct variation and it told me that there in the word problem, I can just do y over x. So I'm going to take my 75, which is my y value, and I'm going to divide by 15, which is my x value, and I get 5. And it is noted here that if you use 0.75, that's okay, because 75% is really 0.75, but it's okay in this situation to just keep it as 75. So 75 divided by 15 equals 5. So 5 is my slope, or my constant of variation. So my equation then would be y equals 5x, or if you use 0.75, you would have 0.05x. So if my equation is y equals 5x, how many questions do you need to answer correctly to get 90%? Okay, so it's important again to make sure that you refer to what 90% is. Is it a y value or is it an x value? So remember, our grade value or our percent values were y values. So this was my dependent variable. So this grade depends on how many questions I get correct. And the questions I get correct are my independent variable. So let's say the answer is 18 questions, but here's how we got it. So if 90 is my y value. I'm going to plug it into my equation that I created. If my equation is y equals 5x, then I'm just going to take 90 and plug it in for y, so 90 equals 5x. And then when I solve by dividing by the coefficient of 5, I would get 18 questions. Okay, so let's look at another example. The power P of a gear varies directly with the radius R of a gear. P equals 300 when R equals 50. Okay, so now is an important time when you want to differentiate between those independent and dependent variables, especially when we're not using X and Y values. So the power P of a gear varies directly with the radius of a gear. The power P would be my dependent variable because it varies directly with the radius. So it depends on the radius. The power depends on the radius. So I'm going to highlight my radius in orange since this is going to be my independent variable. So now I have my two values where I can find my constant of variation. So if P equals 300 and R equals 50, I'm going to set up my y to x ratio. So I'll have 300 over 50. And when I divide those, I get a constant of proportionality of 6. And then my equation would be P equals 6R. So find the radius of a gear which has a power of 510. So once again, I want to make sure that I'm clear on what 510 is. So 510 is my power. So if it's my power, that means it's my dependent variable and it's my y value. And the answer is 85, and this is y. I would plug, looks like, let me correct that for us. Let's see, we should be plugging 510 in here, not 600. There we go. I would plug 510 in for my equation, and equals 6R, which 6 was my constant of proportionality, and then I could divide, and when I divide, I would get 85. Scroll back up, make sure you didn't miss anything here, and remember you can pause to get any of this information. Okay, last example that we're going to do together. So the last one says a dripping faucet wastes a water at a constant rate. The table below shows how many cups of water are wasted over a given period of time. Okay, so we can see in our table, and I'm just going to kind of pull over here so we don't see this other work quite yet. I've got, let's see. Actually, I'm gonna scroll down this way. We don't want to get ahead of ourselves. Okay, so we can see here I've got 3 minutes for 2 cups of water, 6 minutes for 4 cups, and 15 minutes for 10 cups. Okay, so the first thing is to figure out what is my slope. Now I can actually already see that there is a constant of proportionality, and you can see it from my work over here. 2 over 3 would actually equal 4 over 6. So these are my y to x ratios. 2 over 3, 4 over 6, and 15 over, let me fix that. It should say 10 over 15. And all of these could be reduced to 2 over 3. So since they can all those ratios are the same, I know I have a constant of proportionality. So this is going to be a proportional relationship, meaning it goes through the origin. So I'm going to create my equation. Write an equation that expresses the number of cups of water wasted in terms of time, measure in minutes. And when I do that, I can see it's y equals 2/3 x. And really, what should really be here in the place of the y and of the x, really we should have t here, and we should have w. So w would equal 2/3 t. The 2/3 again came from right here, our constant of proportionality. So if we continue, how much water has been wasted a half hour after the faucet started dripping? Okay, so half an hour is referring to my time. So in this case, I'm going to be plugging in for my independent variable, my t, and half an hour is 30 minutes. So when I plug in, it's going to be 2/3 times 30. And 2/3 times 30 gets me to 20 cups. Well, that's going to be it for us today. So here's what I need you to do. Remember, you can go back and get any information you need. Rewatch the video if you need to. But please complete number 5 on your own. Your teacher will check with you on Monday. I hope you have a great weekend.